welcome to Chapter 2, Section 4 for Integrated Math 1, Solving Equations, Variables on Both Sides. So we've reviewed some of these main concepts before. We're just going to go back over them. So identities is when an equation is true for all values of the variable. So if we look at this example here, we have 3 times the quantity or the difference of 2b and 1 minus 7 equals 6b minus 10. So they distribute the 3. That's how they have 6b. It's 3 times 2b, and that's 6b. And then 3 times negative 1, so you can even kind of jump these over here, just so you can see my arrows. So 3 times negative 1 is negative 3. Once they've distributed, they drop the parentheses, and now we can start to group like terms. So we have negative 3 minus 7. Remember, they're both negative, so we combine. And what you might notice right away here is as soon as you combine, why did they do that? That's interesting. So if you combine these, I'm going to cross this off, you would have 6b minus 10 equals 6b minus 10. So they equal each other. They're identical on both sides. So if I started moving things across, if I said plus 10 on both sides, well, the 10s would cancel. If I said plus 6b on both sides, the 6b's would cancel. So really we'd end up with 0 equals 0. Well, that's true. So that's what we call an identity, and it's infinite solutions. That's another way to say this, that the equation has infinite solutions. For your answer, you just write all real numbers or all numbers, something along those lines. But it just means that I can plug anything I want in for the variable, and it will be true. Because since they're identical, if I have 6 times a number minus 10, well, this side is 6 times the same number minus 10. So it's going to be the same on both sides no matter what I plug in. No solution is when literally some equations have no solution. So if we look at this example, we have 5x plus 5 equals 3 times 5x minus 4, quantity, minus 10x. So first, we're going to go through and we're going to distribute this 3, okay? So we have parentheses we're distributing. We have 3 times 5x, that's where they get 15x. 3 times negative 4, that's where we get negative 12, minus 10x. So we just kind of tag it on the end. Once we've distributed, we drop away those parentheses. And now we can combine like terms, not the 12, the 15x and the negative 10. So 15x minus 10x, that's 5x. So now they're not quite the same. They're kind of sort of close. It's 5x plus 5 equals 5x minus 12. Well, if I subtract the 5, really from either side here, it doesn't matter which one, they cancel, right? And we end up with 5 equals negative, the negative dropped away there. It shouldn't have, that should still be negative 12. Well, you should have some questions here. What? That doesn't make sense. 5 does not equal negative 12. So that is a false statement, therefore there is no solution. So if it's a true statement, that means infinite solutions. If it's false, no solution. One solution is definitely our common one, where we have exactly one answer. This happens most of the time. So we have this kind of fun question here. 6 times 5m is 30m. 6 times negative 3 is negative 18. 1/3, remember this means we're dividing by 3. So really it's 24 divided by 3. It's 8m. It's 24m, I just didn't say the m aloud. And then 12 divided by 3, which is where we get 4. So it's the same idea with fractions. I'm multiplying on the top, which is 1, so it doesn't change anything. And I'm dividing the number on the bottom. So everything gets divided by 3. All right, now I can start combining my like terms. So I'm going to subtract 8 from both sides. The 8's cancel. And over here, it's 30 minus 8, so I get 22m equals, and I kind of skipped a step here because it looks like I went plus 18, and I just didn't show it. And that's where the 22 came from, because the 18s also cancel. We put it on this side. So 22m equals 22. We're going to divide by 22 on both sides. So m equals 1, because they really cancel both sides. 22 divided by 22 is the same. So this is an example of one solution, because we know exactly what m equals. It is 1. There isn't any number of possibilities that we could put in, like infinitely many solutions or identities. And no solution would be, you can't put in anything that makes it true. It's just not going to work. All right, let's go to the next page, and we're going to test some of these really quick. So, go away. All right, so the first thing we want to do is start to simplify. So we're going to use PEMDAS. I didn't write this on the last screen, but this is what we were using to simplify. So parentheses, if you can, there's nothing I can do in this parentheses except for distribute. So that is what I can do with these parentheses. I can't do anything inside of them, but I can get rid of them, essentially. 6 times n is 6n. 6 times 4 is 24 equals negative 18. Once I've distributed this, I can drop the parentheses here. So now I don't have any exponents. I don't have any multiplication or division I can actually perform on the side that needs to be simplified, or addition or subtraction, because, again, I'm multiplying by an n. I'm adding 24 to the n, but I can't do these things right now for simplifying. So we're done simplifying. Remember, simplifying goes in from left to right. Now I can start to solve, and I can use PEMDAS to do this. I shouldn't have to go past multiplication, really, for the most part, because I should have already simplified parentheses and exponents. So first, what is being added or subtracted to my variable? I'm adding 24. So I'm going to subtract 24. Boop. And I have 6n. I cancel these guys out, and that's going to equal. And these guys are combined because they're both negative. So I had negative 18. I'm going 24 more negative. So let's see. This is 12, 2, 3, 4. So it's 42. Negative 42. I'm going to divide by 6. Divide by 6. They cancel. Anything divided by itself cancels. N equals negative 42 divided by 6 is negative 7. So this is an example of one solution. N equals negative 7. All right, so in this next one, we want to simplify again. So we have that same issue with the parentheses. We're going to distribute. So 5 plus 2 times n is 2n. 2 times 1 is 2. And now I've dropped away the parentheses, equals 2n. So I can combine some like terms on this left side here. 5 plus 2 is 7, plus 2n equals 2n. So now, if I subtract 2n, we should notice that something is going to happen. It's positive 2n, negative 2n, positive 2n, negative 2n. They cancel the 0 on both sides, and we have 7 equals 0. Well, that's not true, so this is no solution. So remember, this was one solution. This is no solution. It's not true. All right, let's try the last one here. So we have 5 times 2, because we can't simplify this side, so I'm just going to bring it over. So 5 times 2 is 10, plus 5 times 7v, so that's 14v minus 4. Again, I've dropped the parentheses because I've distributed that 2. I don't need the parentheses anymore. So we can start combining some like terms here. So we have 14v plus 6 equals 10 minus 4 is 6. So we have 6 plus 14v. Hopefully, we can see this right away, and we can see that they are matching. The left and the right side are exactly the same, with the exception that they're flip-flopped, which is fine. That's one of our kind of beginning properties that we learn, is that we can flip-flop these around. So it's the symmetric property, right? We can, I can say 14v plus 6 equals, or sorry, this is the commutative property, I believe. I was saying symmetric, but symmetric's a little different. Symmetric is flip-flopping the entire equation. But this is just moving them around. Because they're all addition, it means the same thing. I have positive 6, positive 6. Positive 14v, positive 14v. So if I started trying to solve this, if I didn't notice, and I subtracted, these would both cancel. And I'd have 14v equals 14v. If for some reason I still didn't notice and I decided to subtract 14v, they would cancel again, and they'd become 0 equals 0. This is true, so it's infinitely many solutions, or all real numbers. All real numbers. This is the number symbol. It's not a hashtag. This is just an example of that identity. All right, so that was all of section 4, and I will see you in section 5.